Hi dear students, let's see this question that came in JEE Advanced Paper-2 2018 in the section of physics. इस क्वेश्चन में basically what is happening is that there is a large tank in which we have put a viscous liquid and there is a square plate which is being moved at a constant velocity u naught in the horizontal direction. The height of the liquid is h, which is considered very small with respect to tank, and we have to comment upon the like nature of the resistive force which is acting on the plate. We have to talk about the stress, tangential stress acting on the plate, and we have to talk about the tangential stress, like how is it dependent with the viscosity eta of the liquid. Okay, so these are the options that we have to talk about. So the question is fairly simple, the formula based question. So basically, suppose this is the bottom of the tank, okay, and this is the plate which is being moved at a constant velocity of u naught in this direction, and this is the liquid, right? So in the question we have been given that the height of the liquid is h, and this is very small, otherwise the velocity profile will not be linear actually. So for the velocity profile to be linear, this should not be very large. Okay, so we can say that h, the force in this case is nothing but eta, which is coefficient of viscosity, into area A of the plate, which is the base area of the plate. Okay, so base area of the plate will be A, into dv by dy, okay, which is velocity gradient. We are calling this axis as y-axis. Okay, so in this case, since h is very small, so we can consider this as a linear velocity profile. So dv by dy will simply become u naught upon h. This will be the resistive force acting on this plate. Okay, so if you go back to options, the resistive force of the liquid on the plate is inversely proportional to h. It's the correct option, because you can see that force is actually inversely proportional to the h. So this force on the plate will be acting in this direction, in the opposite direction. Okay, so there must be some external agent who is pulling the plate such that the plate actually moves with constant velocity. So the force applied by the external agent will also be equals to F in this case, right? Assuming all other forces to be absent, if we assume that there is only one resistive force F, which is of viscosity, so there must be an external agent who is balancing this force. Okay, so go back to option B. The resistive force of the liquid on the plate is independent of the area of the plate, which is definitely wrong, because force is proportional to the area. We can see that. If you go to option C, the tangential stress on the floor of the tank is increases with u naught. So what is the stress? Stress is tangential stress is force per unit area. So if you divide this by area, this will become eta into u naught upon h. So which we can see is actually increasing with u naught. So option C is also correct. If you are having a doubt that this is the shear stress acting on the tank, floor of the tank, but here we have written the stress acting on the the plate. So these two are different things. So actually not. If you try to find the resistive force between any two layers of the liquid, it will come out to be same. For example, if we try to find the resistive force, suppose at this, between these two layers, which is at a height of h by 2, okay, which is at a height of h by 2. So what I'm trying to find, I'm trying to find the resistive force between the two layers of liquid, which will be at a height of h by 2. So you can think that one layer is at a height of h by 2 and one is slightly above that, so at a dh height above. So there will be two layers of the liquid which we can say are at the height of h by 2, and we have to find the resistive force between them. So again, what are you going to write? We can say that the force F dash will be equals to eta into A, where A is the, again I'm taking the same area A of the layers, eta A into velocity of this, which will be u naught by 2 actually, because we can say velocity is varying linearly. So u naught by 2 divide by this height, which is h by 2. So we can see it comes out to be same, F dash equals to F. So that's why I'm saying stress between tangential stress between any two layers of the liquid will come out to be same. So on the floor also it will be same, and hence this is the correct option. The tangential stress on the plate varies linearly with viscosity eta of the liquid, which is again correct, because stress is nothing but eta into u naught by h. So option D is also right. Hence you can see that this was an easy question, and in my opinion, like most of the students who qualified advanced would have done this quite comfortably. That's it. Thank you.